In this example, we are going to take a look at an equation that has variables on both sides. So let's take a look. It says, solve the equation, check the solution. Our equation is written as 6x's added 2 is equal to 3x's subtract 1. And what I'm going to do is I'm going to draw myself a little picture of this equation just so I can visualize what happens as we go through and use our different properties to isolate the variable. So this picture is going to be a representation of a scale, balanced sides. So on one side of the scale we have 6x's, so I'm going to write that as 6x's, 1, 2, 3, 4, 5, 6. And with those 6x's, we have the number 2. So I'm going to use a box, or I should say a square. I'm going to put that 2 in that square to represent a positive 2. On the other side of the scale, we have 3x's, and we are subtracting 1 from those 3x's. Subtracting 1 is the same thing as adding a negative 1, so I'm going to use a circle to represent negative, and I'm going to put in negative 1 for subtract 1. Okay, now let's look at our options and as far as isolating the variable. As we look here carefully, we'll notice that we have x's on both sides of the scale. So as long as we eliminate the same number of x's from both sides, we're fine. So using the subtract property of equality, I'm going to take away 3x's on the left side of the equation, and I'm going to take away 3x's on the right side. Okay, so to do that, it would look like this. Take away 3x on the left side and take away 3x on the right side. We'll notice that we have in this picture 3x's left, and sure enough, 6x take away 3x is 3x. We still have our positive 2, and on the other side of the equation, the x's are gone, but we still have the negative 1. The next thing we need to deal with is this 2, because we need to eliminate it in order to isolate the variable. Well, the opposite of a 2 is a negative 2. A 2 and negative 2 are additive inverses. So I'm going to go ahead and put in a negative 2 on this side of the equation. But if I do that, I need to maintain balance, so I'm going to put a negative 2 on this side as well. And I'm going to represent that in our equation as the subtract property of equality. I'm going to do that in white there just to distinguish this inverse operation. A negative 2 and a positive 2 make 0. They are additive inverses, so they're gone. So we can rewrite our equation as 3x plus 0 is equal to, and a negative 2 and a negative 1 make negative 3. We're almost done. Now that we know that 3x's are equal to a negative 3, the last step is to divide by 3 to find the value of a single x. 3 divided by 3 is 1, so 1x is equal to negative 1. So there's the solution there for x. Now let's do a quick check to make sure we ended up with the value we needed to. So our original equation had 6x's added to 2, so where the x's are, we'll just put a negative 1, and that is equal to 3x's, which are now, each x is now negative 1, subtract 1. Well, 6 negative 1's make negative 6. We're going to add that to 2, and that is equal to 3 multiplied by negative 1 is negative 3, subtract 1. Negative 6 add 2 is negative 4. Negative 3 subtract 1 is negative 4. Those two values are the same, so the solution checks. So x is equal to negative 1. In this next example, it says solve the equation, check the solution. We have the equation 2s add 15 is equal to 2s add 20 subtract 5. Well, let's take a look here. So we have 2 s's. We're adding that to 15 is equal to 2 s's. And 20 subtract 5 is 15 as well. So if you look carefully at both sides of that equation, no matter what value of s we can think of, the two sides will always be the same. So all values are true for this equation. This is what we call an identity equation. No matter the value, both sides will remain the same. And just to check that, we'll just pick a random number. 0 is always a good number to check, because when we put 0 into the equation, 2 times 0 is 0, added to 15, is equal to 2s, again, 2 zeros is 0, added to 20, take away 5. And sure enough, both sides of the equation are 15, so no matter what value you pick, you're going to get the same number on both sides. So there's a good example of an identity equation. In this next example, we have solve the equation, check the solution. We have 18 added to 3x is equal to 22 added to, 3k is equal to 22 added to 3k. All right, now as we look at this, we can see that we have a problem, because no matter what value for k that we choose, there is no value that will make both sides equal to one another. So there's no way to make 3k's added to 18 equal to 3k's added to 22 when the k is the same value. So this is an example of what we call a no solution. And just to verify, I mean, we could check any number of values, but again, let's just check with 0. So we have 18 added to 3 times 0 is equal to 22 added to 3 times 0. So 3 zeros are 0, so we have 18 on the left side of the equation. 3 zeros on this side are 0 is equal to 22, and 18 is not the same value as 22. So again, this is an example of an equation that does not have a solution. In this next example, we have solve the equation, check the solution. And so this is a good one because it has a lot of steps to it, so it's a good one to go through. So we have, let's start with our 2x's. Now remember, subtracting is the same as adding opposites. We have two groups here, and each group has a negative x, add 4. But if we're going to add the opposite of each of those groups, we end up with 2. The opposite of 2 negative x's is 2 positive x's, and the opposite of 2 4's is 2 negative 4's. And negative 4 and negative 4 make a negative 8. And that side is and then on the other side we have is equal to x plus a negative 2. Okay, so what I'd like to do on this side is just like we did before. I'm going to draw a little picture of a scale to represent the balance between the two sides. I'm going to draw a picture to represent the equation. We start with 2 x's. It looks like we're adding 2 more x's, and then we're adding a negative 8. So again, I'm going to use a circle to represent the negative number. On the other side of the scale, we have an x, and we're adding a negative 2, again in the circle. If you notice here, when we look at all the x's that we have, that's a total of 4 x's. So when we combine like terms, we end up with 4 x's added to the negative 8 is equal to, on the other side of the scale, we have an x added to negative 2. Now, as we focus our attention on both sides, we can see that we have at least one x that we can eliminate from both sides. So using the subtract property of equality, we're going to take an x away from this side, and we're going to take an x away from this side. So we can represent that as subtract x from both sides. Okay, when we do that, we have 3 x's left plus the negative 8 on the left side of the equation. And on the right side, we took away the x, so that's gone. And so we have a negative 2. Okay, the next thing we want to focus on is this negative 8 here. We're trying to isolate the variable to solve for x, so we have to make that negative 8 into 0. We can make negative 8 into 0 by adding a positive 8 to the negative 8. These two values are additive inverses of each other, and so they make 0. So we can go ahead and add an 8 to this, a positive 8 to this side, as long as we use the addition property of equality and add an 8 to the other side of the scale. So let's go ahead and do that in our written equation. So we're adding 8 to both sides. These two values make 0, and these two values, a positive 8 added to negative 2, make a positive 6. So we can rewrite the equation as 3x add 0, so we'll just leave that 0 off, is equal to 6. Now that we know that 3x's are equal to 6, we just divide by 3 to determine the value of x. 3 divided by 3 is 1, so we have a single x is equal to 2. Now to check, all we need to do is plug that x value into the original equation. So we have 2 times x, so we have 2 times 2. Subtract 2 multiplied by the group, and in our group we have negative x, which is now negative 2, add 4, is equal to this x is now a 2, added to negative 2. Oops, we don't need that x in there anymore because we did our substitution. Okay, so now we have 2 multiplied by 2 is 4. A negative 2 added to 4 is negative 2. And so 2 times negative 2, a negative 2 added to 4 is 2. And so we're going to subtract 2 times 2, which is 4. And on the other side, we still have the 2 added to negative 2. 4 take away 4 makes 0. 2 added to negative 2 makes 0. And so sure enough, x equals 2 checks, so that's the solution.